Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answer. So for the factoring, you're going to do remove, replace, reduce. So you're going to do 7 times 8. So you're going to have x squared minus 30x plus 56. And then you're going to factor it as x minus 28 and x minus 2. And then you're going to replace your 7. The first one will divide by 7 to give you x minus 4. And then the second one is going to stay as 7x minus 2. Okay, so that would be your factoring. For the math knowledge question, your formula is A equals P plus PRT. Which of the following gives P in terms of A, R, and T? So we're solving for P. So on the right side, we're going to want to factor out a P. So we'll have 1 plus RT. And then you're just going to divide by 1 plus RT. And that is given by A. So that would be your answer. Looking at lesson 30 today, we're doing graphs of tangent and then graphs of reciprocal functions. So hopefully you understand the graph of tangent. You should have seen it last year in pre-calculus, so hopefully it'll be a little bit of review. And then we're going to look at graphs of reciprocal functions. You also should have done reciprocal functions last year in pre-calculus, so hopefully those will be review as well. This is the graph of tangent. These asymptotes occur at negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, etc. If you think about your unit circle at 90 degrees, which is pi over 2, and at 270, which is 3 pi over 2, tangent is undefined, and that's why you have an asymptote there. So if y'all need to pause the video to graph that real quick, you can, but you need to learn what the graph of tangent looks like. So we're going to use the graph of sine to sketch the graph of cosecant. And so I've got the graph here, and so if you want to wait for me to pull that over, I can. I'm going to show you where it comes from though. Alright, so sine, I'm going to do in green. We're going to have pi and 2 pi and negative pi and negative 2 pi. And then everywhere that sine crosses the x-axis, you're going to have to put an asymptote. So here, here, on the y-axis, here, and here. And then everywhere that it equals 1 and negative 1, you're going to put dots, because the reciprocal of 1 is still 1, and the reciprocal of 0 was undefined, because something divided by 0 doesn't work. So that's why you have asymptotes here. And so this would be the basic sketch of cosecant. If you look there. But I'm going to pull out the book's graph so that you can see what it looks like. It looks a lot prettier. But if you filled in, sine would come right here. Okay, so you want to pause the video to graph cosecant of x, and then we'll go on to the next one. We want to use the graph of cosine to sketch secant. So I'll do it in blue here. So this is pi over 2 and 3 pi over 2, negative pi over 2, negative 3 pi over 2. And again, everywhere you cross the x-axis, you put an asymptote, because the reciprocal of 0 is undefined. And then this is where our 1 and our negative 1 happen, and so everywhere those happen, you put a dot, and then they approach your asymptote. So it kind of looks like a lot of U's. So that would be how you get secant. So again, here's the book's little graph, and I'll graph cosine into it so that you can kind of see where it comes from. And there's your cosine, which doesn't look so lovely over here. But that's what you would get. Okay, so y'all can pause the video real quick, and then we're going to go on. We're going to use the graph of tangent to sketch the graph of cotangent. So tangent's the one that we started with at the beginning. Okay, and so this is the origin. This is pi over 2 and 3 pi over 2, negative pi over 2 and negative 3 pi over 2. And I'm going to do cotangent in black. So everywhere that it crosses the x-axis, you're going to have an asymptote. That first one should probably be a little bit further to the left. It's supposed to be halfway in between these values. Okay, so it should be crossing right here, here, and about here. And then it's going to actually end up flipping this direction. And so it's supposed to have the same curve as tangent. It's just rotated, translated, flipped, whatever you want to call it. Okay, so that's what it looks like, and I'll show you the computer generated graph in case you want to graph it. But they have the asymptotes from tangent drawn to show you where you cross the x-axis for your cotangent. So y'all can pause the video real quick if you want to graph that one. So now we're going to look at another example. We want to graph cosecant of theta plus 45. So the first thing that you want to do on these is to graph the sine of theta plus 45. So we're going to graph our little sinusoid. And sine normally is going up through the origin. But instead of it going up through the origin, it's going to be going up at negative 45 degrees. Okay, and then there's no period change, so add 360, and that puts you at 315 right there. And then there are 4 of these, so add 90 to put you at 45, 135, and then 225. So our y-axis is going to go right here. And so that would be sine. Now I'm going to do in green cosecant. So we're going to have asymptotes there, 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 and then we're going to have our little u's. And so you could keep going on your graph. But that's basically what it would look like. Okay? So now we're going to look at graphing the secant of theta minus 20. So again, we're going to start off with the reciprocal, which is cosine. And so Cosine normally hits a maximum, but this time it's going to hit a maximum at 20 degrees because it's always the opposite of whatever number you have. Okay, so if we go forward 360, that would be 380. If we go backwards 360, that would be negative 340. And then they're going to be every 90 degrees. So if you added 90, you'd be at negative 250. Added 90, you'd be at negative 160. Add 90, you'd be at negative, I think I'm right. You'd be at negative 70. Add 90, you'd be at 20. Add 90, you'd be at 110. And then you'd be at 200. And then you'd be at 290. And then you'd get to the 380. Okay, so this is our theta axis. And our y-axis is in between negative 70 and 20. I'll put it right there. Hopefully you're remembering how to graph these. That shouldn't be review. And then I'll do secant in blue. So everywhere you have it crossing the x-axis, you're going to put an asymptote. And then you're going to do your little u's. Okay, so there you go. So that's how those work for your sine, cosine, tangent, secant, cosecant, and cotangent. Now we're going to look at reciprocal functions of other kinds of graphs. So there are two things you need to remember when you're graphing your reciprocal functions. Everywhere you cross the x-axis is going to create a vertical asymptote, which is what we were just doing. So if it crosses your x-axis, that creates vertical asymptotes. So this one only crosses the x-axis at 2. So we're going to put one vertical asymptote there. The other thing you need to remember, the reciprocal of 1 and negative 1 is still 1 and negative 1. So everywhere that it equals 1, we're going to put a dot. So right there. Everywhere it equals negative 1, we're going to put a dot, which is right there. And I'm going to go back real quick. This is where it was equaling 1 at these 3 maximums. So that's why we put dots there, there, and there. And then it had negative 1 here and here. So that's what we were doing. So those are the two things you need to remember for your reciprocal functions. And then from there, you're going to just do that. And, whoops. That. And so that's the graph. It's always going to approach your asymptotes and approach the x-axis. You can only cross the x-axis if you have a dot there. So that's how that reciprocal function works. So let's look at this one. We want to do our asymptotes first. So where does it cross the x-axis? It crosses at negative 3. It crosses at negative 1. And it crosses at 2. Okay, and then we're going to put dots where it equals 1. So 1 is right here, another one is here, and then another one about right there. And then it equals negative 1 right here. And it looks like there may be 1 there, or it may be 2 that are right there and there. It'll be okay either way. Okay, so now we're going to start over here. We're close to our x-axis, and we're going to go through our dot and approach our asymptote. Now we're going to jump at our asymptote, and we're going to go through our dot. And now we got a problem because we've got a dot over here. And so we have to go through that dot. So the only way to go through that dot is to go to it. So we have to cross our x-axis, and then we approach our asymptote. Okay? And the reason I crossed at 0 is because, do you see how on the left side it's approaching positive infinity, and on the right side it's approaching negative infinity? That means that there's an asymptote at the y-axis where x equals 0. And so the reciprocal of an asymptote is a 0, which is where a dot comes from. So that's why we cross at 0. So then, to get across this asymptote, we jump down here, and we're going to go through this dot, and we're going to go away from it. We're going to make a little U. Or you could come up kind of this way and make a wider U. It's okay either way. You'll still have a U down here. Again, you're going to jump across your asymptote and go through that dot and then approach your y-axis. So that would be your graph for that one. So hopefully you remember doing reciprocal functions. Again, these are the two rules that you need to remember. When you cross your x-axis, you change it into a vertical asymptote, and then the reciprocals of 1 and -1 are still 1 and -1. So your homework, you do get to omit number 15. So make sure to do the other problems tonight for homework so we can go over any questions that you have tomorrow.